All right. Welcome, everybody. Come join in. I'll wait for people to start filtering in. I see Paul Puglia's here. Good to see you. I'm Mike Slender. There's a lot of folks coming in. All right.
Yeah.
And we'll just sort of sit here semi-awkwardly as people filter in. We get people in the door. And welcome, everybody. Hope everyone has a good first day of December. The year is almost over. I think we could all be excited about that. I think most people would agree we're ready for 2020 to be done. Yeah. All right, a bunch of people coming in. I'm going to just slip over here and get my slice of pizza. All right. And we'll see as everyone comes in. I'll start my announcements in a little bit. Hello, hey, Noam. Well, you have to be here. You're our sponsor. Hey, Ken. Good to see you, Ken. Let's see who else I see his names. If I don't call out your name, it's because I don't see your name pop up necessarily. And also, I don't, I can't call it everybody's name comes here. We'd be sitting here all night just calling out names. All right. Okay, so we will slowly get started with the announcements as some more people trickle in. All right. So first things first, we always like to start the meetups with a question of who is hiring. For obvious reasons, we can't have everyone offer jobs like we normally do when we're in person. I guess normally, we've been doing this for like 6-7 months now. So maybe normal's, the old normal, we had people just shout out jobs. So because we can't do that, please join the Slack team. And Amada, I think you could post a link to the Slack team in the chat. There is a channel called Job Postings. Post your job there. I know that we've had a few, over the past 10 plus years, we've gotten lots of people jobs from in person, but now we're getting people's jobs just through that Slack channel. So it's a zero cost way of trying to hire people, and just let's get more and more people jobs. So please go in there and post your job. So again, we will hopefully be able to do that again in person, but we're hoping for all that to be in person. All right, next up. I hope everyone has their pizza. I know we can't be in person. This has been delivered a little bit, but we have cheese lock, which is a good sign. See the bottom? It looks like it's uniformly charged, no char marks. So if I had to bet, this would be in a gas oven. This is from a place called New World Pizza this time. Will, you've been to a few of our meetups. You know that we are obsessed with, I'm obsessed with pizza, and we have pizza every month. And until the pandemic, we had a pizza poll. And by the way, folks, the data is still freely available. It's all at jaredlander.com/data/pizzapoll.php, something like that. And it's a JSON feed. It was live, but now we don't have live polls anymore. And some people have used it. Tidy Tuesday used it, and Thomas Levine made a painting of the data. So feel free to go use that data, folks. So big week this week. This is our second R week of the year. We had the virtual New York R conference back in August. So this year, we normally would be having a Washington, D.C. conference. We thought since we can't be in person, we could be anywhere. It is an R in government and public sector conference. It is anything involving policy and governance. We have speakers from NASA, from Air Combat Command, from InQtel, the New York City Department of Mental Health and Hygiene, the New York City Council, the Census Bureau, the Bureau of Labor Statistics. I could go on and on. And we recently added, I'm very excited we added Graciela Cinciolinski. She is an economist who was one of the key authors on the Kyoto Protocol. I was very excited. She was my professor back in grad school, so I emailed her, hey, do you want to come give a talk about a policy conference? So I'm super excited. I was excited I took that class of her 10 years ago, but I'm definitely excited that she's coming to come speak. So we're excited for this conference. The workshops start tomorrow. In the workshops, we have 3 workshops. Causal inference, which is so hot these days. That's with Lucy and Malcolm. We have mapping for policy with Kaz, and we have machine learning for policy with John. I'm not saying anybody's last names, but you can go to the website to find their last names. If you want to attend the conference or the workshops, use the meetup code. Any events we put on, it's for this meetup. It grew out of this meetup. NYHackR is your 20% discount code. It works on any event we put on. And I think we promoted a Python event recently. It might have already taken place with James Powell. There was a discount code there. We always try to give you discount codes. I think the Python event already took place this past week. I hope some of you attended. Hope it was awesome. I wish I could have attended. I love James Powell. Just couldn't make it. Too busy running up to this conference. The way this will work, since we can't ask questions in person, as we're all aware, ask the questions either in the chat window here or in the Slack meetup. There is an event called December 1st Meetup. A channel called December 1st Meetup. If you go in there, you can post your question, and at the end of the talk, I will go through the questions and ask them of Will, and Will will hopefully answer all those questions and not dodge any of them. Just kidding, we don't have any speakers really dodge. Thank you to EcoHealth Alliance and Noam and Emma for providing the Zoom for us. It is very helpful having them provide the Zoom every month. It really makes this thing work. We do have the next 3 months starting to be planned out for the meetups. We will announce those after the conference. So sometime, hopefully next week, we'll give an announcement about that. We actually are scheduling months in advance now. So if you want to give a talk, send us an email and we'll tell you, okay, you have 6 months to go. Or we might tell you, hey, you need to go next month. Both have happened. Right now you have a buffer, but both have happened in the past. So I think that is all the announcements I have. Just to remember, jobs, posted in job postings, ask your questions in the meetup channel called December 1st Meetup, roughly called that. Join the conference this week if you're feeling that. Thank you, EcoHealth Alliance, and I'll see everyone afterwards. Hopefully we'll get to see you again in person soon, but until then, I'll enjoy doing these virtual meetups. With that, a few months ago, we had a talk from Miles McBain talking about the Drake package. And during that talk, the author, Will, was there, and I saw his name, he asked a question, I'm like, hey, you're gonna give a talk at the meetup. And he politely agreed, and here he is to talk about targets, which is the follow-up to the Drake package. And I'm super excited to learn, because I just learned Drake, so I'm excited to learn a new thing now. So everyone, please give us a virtual round of applause that he won't be able to hear. Please welcome Will. Thank you, Will.
Well, thank you, Jared and Ameda, for organizing this, and to EcoHealth Alliance for the infrastructure. This is an incredible meetup with not only a large audience, but a great group of people and a source of really thoughtful questions. I enjoyed the last couple of talks I've attended here, so I'm excited to present. With that, I'm gonna try and share my screen. It may take a couple of tries in Zoom. Can everyone see and hear?
Yes.
Wonderful. So today I'm going to talk about targets, and like Jared mentioned, it's the successor to Drake. Originally, I knew this had to be developed after a couple of years of secretly sort of mulling this over, and I mean, comments like Jared's are great because it just affirms that the R community is incredibly open to and excited about change and about growth, and this is hopefully a little way to contribute to that, and it makes it super exciting to offer improvements and to solve problems that we're dealing with and to attack them creatively. So I come from the life sciences, and we develop ambitious computational workflows for statistics and data science. So there's a lot of machine learning and Bayesian data analysis and simulation and prediction, and other domains have similar kinds of workflows, and we need to think about both efficiency and reproducibility right from the get-go. And many of these projects have long run times. Methods like Markov chain Monte Carlo and deep neural nets are computationally expensive, and it could take hours or even days just to fit a single model. That's fine if you're only going to run the project once or at regularly scheduled times, as in an Airflow setting. But if the code is still under development and you still need serious results, it's easy to get trapped in a vicious Sisyphean cycle. So a large project has a large number of moving parts. We have data sets that we pre-process or simulate or just procure. There are analyses of those data sets and summaries and plots and tables, etc. And if you change any of these components, whether it's a bug fix or a tweak to the model or some new data, then everything that depends on it is no longer valid. And you need to rerun the computation to bring the results back up to date. And it's seriously frustrating when you're in development and you're still making a constant stream of changes to code and data in real time. So if every change means you need to rerun the entire project from start to finish, there's just no way the results can keep up, unless you use something like a pipeline tool. And there are pipeline tools for production, which resemble Apache Airflow, and there are pipeline tools which resemble GNU Make. And I'm going to focus on the latter today, the make-like tools, just because I think they're better designed to skip artifacts and computation that are already up to date and make this sort of iteration that I described a bit easier. Whether you're in the airflow space or which solves a slightly different but equally valid set of problems, whether you're in the airflow space or the make-like space, both are action-packed, and there are a lot of amazing options out there. Historically, though, there hasn't been a whole lot for R. And that's where targets comes in. So targets is a make-like pipeline tool that's fundamentally designed for R. So you can call it from an R session. It supports a clean, idiomatic, function-oriented style of programming. It abstracts artifacts as R objects. You don't need to work with the output files directly in most cases. And most importantly, it gets you out of the Sisyphean loop of long computation. It enhances reproducibility, and it takes a lot of the frustration out of data science. So let's go to an example. And at this point, sometimes I pick a machine learning example that I borrowed from folks at our studio. Sometimes I pick a simulation example. There is, at a conference recently at R Pharma, I talked about a COVID-19 clinical trial simulation example that was close to my own work. But here I'm taking a little bit of a turn to make this particular presentation a bit more unified, because I have an announcement at the very end, and this is going to lead up to that. So we're going to take a Bayesian model that you see here, and we are going to try to check that we implemented it correctly. So I'm going to try not to assume knowledge of Bayesian statistics, but just know that this is a statistical model. It's going to be implemented in a probabilistic programming language called Stan, and we are going to validate this thing. And that means what we're doing is we have a workflow, and not all validation workflows happen like this. So this is just one way we could validate the implementation of this model. We're going to develop a pipeline where we simulate 1,000 data sets from this model, 1,000 random data sets. We're going to fit the model to each of these data sets, this model you see here. And this is where it gets a little bit esoteric. We're going to check the output of the model against the parameters that we use to generate the data, and see if we can recapture the truth behind the simulation. And for those of you who are Bayesians out there, we're going to calculate the 95% credible interval on this beta slope parameter, and we're gonna count how many times the estimated credible intervals in all the simulations cover the true value of beta from the data, and that coverage rate should be close to the nominal value of 90% if the model was implemented correctly. And there are other ways, like I said, to validate models. I found this one to be quite good. It's caught errors in the past. And we're going to use Stan, like I said. It's a black box MCMC probabilistic programming language. It's super popular. I've been using it more and more, and I can say I'm an extremely satisfied customer here. And this is how we would write the model in Stan. This is just it's pretty natural most of the time. And this is going to exist as a file in our workspace when we set up the project. We're going to also need to write some custom functions to make this work happen. So targets is very function oriented, and that is intentional. We're using functions because they scale well. And if you have a large code base and an ambitious project, it's natural for R. So R borrows a lot of elements from functional programming, and it fits the paradigm of data analysis in general. So data analysis you can think of as a series of transformations from data to model objects, from model objects to summaries and things like that. And it just fits the paradigm so well. And in terms of tracking outputs and changes to targets, functions just make this all come together and all possible. And I know it's sometimes maybe difficult for those of you who are used to script-based workflows, like our Markdown documents for most things, or the slug-based paradigm where you have numbers to index your imperative scripts, like say 1-data.r, 2-model.r, and so on. We're going to try to get away from that for the purposes of targets, because because of the issues I described. And functions, once you get used to them, can be a tool to help you. They may be intimidating at first, but really all they are is a way to express one of those data transformations in a workflow. So most of the functions that we're going to write are either fall into one of three categories. So number one, a function to generate the data, like the one that you see here. Another class of functions is a function to fit a model, like this one, where you take the data, and in this case, the model file, and you fit the model and you return some sort of fitted output. And that's sort of another major class of function. And another, you might write some more functions to generate summaries, like plots and reports, and even deploy outputs to say our Studio Connect or something. And yeah, those can be split up into different functions, but those are the main sort of three reasons why you would write a function in a data analysis workflow. Including these utilities which support the main functions. And once you write these functions, you would organize them into files any way you want, but this is a way I like to do it, and this tends to be sort of good practice for maintaining a hygienic workflow. So I'm defining a folder called R, and this is where I put the scripts where my functions live. And you'll notice this, for those of you package developers out there, this looks kind of like a package where you define a bunch of functions in a folder called R. And some people do like to write packages. I'm working on making targets a little bit more amenable to packages as sort of one-off workflows. And I actually broke through today and solved something a technical problem that may make this practice a whole lot easier. But you don't need to go that far. You don't need to actually develop a package for your workflow. What we're really after is a research compendium, just a repository with all your code, such that if you give it to somebody else and they run it, they could reproduce the same results that you have, and they could read and understand not only your output but the process that led you to get there. And that's part of what a research compendium does. Ben Marwick has written extensively about this, and he maintains tools around this. So I recommend you check that out for best practices of general how you set up these kinds of projects. Because as Miles McBain said in his talk, Drake and targets and tools like them don't really have an opinion about how you set up your project structure, and that's deliberate. They're tackling an entirely different set of problems. And I think the research compendium paradigm tackles those problems. The thing that's specific to targets itself is this _ targets.R file. Everything else looks like a regular research compendium, or however you want to organize it. But this targets.R file is special. So it's a configuration file that is required and needs to be at the root of your project and your working directory when you actually run the computation and most helper utility functions. And this is what it looks like. So this targets.R file, it's going to begin by loading the packages that you need to define your pipeline at a high level. It loads your functions and other global objects. It sets options, and these could be global options in R or target specific options, like the packages that the targets themselves need to actually run the workflow. You don't need to use this packages setting necessarily, but it does end up making a lot of things faster if you do. The alternative is just to skip this and write regular library calls for all of these things up top. And then, so that's the top of targets.R. The bottom of this is where you define a pipeline object. All targets.R files must end in a pipeline object, which should be a call to tar pipeline. And for those of you who have used Drake out there, this is kind of like your Drake plan. And for those of you who've used make, this is kind of like a make file. And For those of you who aren't familiar with any of these, that's totally fine. This end of the targets.R file is an outline of the high-level steps of the analysis. And each high-level step of the analysis is called a target. And each target has a name, like model file here. It has a command in R, which gets run not right away, but this part gets delayed, but this code gets written in here and quoted, plus a bunch of other settings. But at minimum, you have a name and you have a command, all wrapped into this a call to this target function, which returns a target object, which goes into this pipeline. And each of the steps of the analysis is going to have one of these targets. So there's a target for the stand file. This is a compilation step. And here is another step to simulate the data. And when we go to the model fitting steps, they will also be targets. And we're only going to add a few targets to start out with. So what I highly recommend when you start a pipeline is not to throw everything in all at once, but just to get a couple of targets going, inspect your workflow, run them, and then add, rinse, and repeat. You can do this iteration because of how targets manages the computation. It doesn't actually end up being that expensive, and this gradual process helps make sure things don't get out of hand. So once you define this targets.R file, you can immediately inspect it and make sure that you've set up everything correctly, because you don't necessarily want to commit to a super large computation unless you know that things are going to flow properly. So this graph is actually, it's not interactive in the slides, but it is interactive in real life. You can click and drag and zoom these nodes, and you can get a sense of how things are connected. So this data continuous target is connected to index sim and index batch, and I'll explain a little bit of that about a bit later on. But the reasons why these targets are connected in the way they are, this data continuous target needs in this case an index to label sort of the batched computations that I've set up, and the number of and another index target here with simulations within a batch. And because we're simulating a lot of data sets, and we want to group them strategically into manageable collections here. But the point is that this data continuous target depends on these upstream targets, and this is automatically detected. It doesn't matter the order that you specify the targets. What's going on is that this data continuous target mentions the symbols index sim and index batch in various places, the command, and then this dynamic branching command down here, and as well as the simulate data continuous function. And what's nice is that targets automatically crawls through all that and automatically detects that the index targets are dependencies of this data target. Things in this graph should generally be connected so that targets so that your targets proceed in the correct order. Likewise, this model file target depends on a bunch of functions. It depends on this compile model function, which depends on this utility function called quiet, because compile model is mentioned here, and that's a custom function to just compile the stand model. It's a little wrapper, and that is automatically detected here. And those dependency relationships are important because targets is going to automatically detect changes to them and automatically and strategically rerun only what needs to rerun and skip things that are already up to date, which saves a lot of time in the case of Bayesian data analysis. So after we're satisfied that we've set things up correctly, we can actually run the workflow. And this is going to use that graph that I mentioned. So what's happening here is this tar make function is proceeding through the graph, running the correct targets in the correct order. So it's running a target called batch index, it's running a target called model file, and then it's running these data targets that depend on some previous steps. And at the end of the day, if you rerun the pipeline again after that's all done and nothing has changed, then it's going to skip these targets because they're already up to date. Now, you may have a workflow where this matters because in some cases, it may be expensive to simulate that data from a model. Maybe the simulation procedure itself is time consuming, and skipping these steps saves you several hours or even just a few minutes of time. And if you're developing code really fast, that's extremely helpful. We can check the graph again to make sure, and other utilities like it to make sure that now our targets are up to date. So we know what we're going to get in advance before we run the pipeline again. At this point, we can read our output. So we can read individual data sets with tar read or tar load. We can pull any target we want from the cache, because a target is associated with a return value that's stored locally in a folder called _targets. And those files live there. They're going to be in your project. And but you don't have to think about those actual files, where they live or what they're called. You just need to know the target names. And this makes it super easy to do exploratory data analysis. You know, the exploratory data analysis is something I get asked about a lot with these pipeline tools because a lot of this is rigidly structured formal pipelines. And it seems like everything's automated, but we have exploratory data analysis too, because of how easy it is to retrieve the results. This is much better than trying to manually organize files. It gives you a lot of convenience and peace of mind. And at this point, if we check the results, we experiment with them a little bit, we're satisfied that we've gotten reasonable answers, we can move on. We can add some more targets. We can actually start to fit this model, which is going to say, for each data set that we've simulated, we are going to take this batch of data sets, and we are going to simulate, we're going to fit a continuous covariate version of this model to each one. And after we add that to the pipeline and we visualize the graph again, we see a couple of good things here. We see that, first of all, this fit continuous function is connected to the upstream targets and functions, and like it should be. And it's the data and the model file. And also, it's the only target that's out of date right now, because we left everything else the same. We didn't change anything, but we have this new target now. And so when we run tar make again, we only run the models and we skip everything upstream. Because it's already up to date in this particular case. Now, tar make cluster MQ is a new one. So I chose this because in this particular case, these targets were pretty inexpensive and could run locally just fine. But when I ran this in scaled up fashion, these models actually took quite a bit of time. Even though this is a very simple model, MCMC takes a long time. There is, especially even if it only takes a minute or so to validate a model like this, in the approach that we're doing, we're simulating and we're running 1,000 different models, this model 1,000 different times, and that adds up to about 45 minutes in this case. And so one of my works, Sun Grid Engine cluster. And I set some options in the _targets.R file to connect to cluster MQ to the Sun Grid Engine cluster. I selected a number of workers, and these are going to be, and when I called tar make cluster MQ, a bunch of targets, these model fitting targets, ran in parallel on different nodes of this supercomputer, and it got the runtime down to about 3-ish minutes. And when at this point, let's go around that loop again. Let's inspect the results, and we see that we've got what we want. We have a bunch of summaries for each of the models that we fit, some summary statistics on the posterior samples. And for Bayesian modeling workflows in general, I would recommend actually, if you're only running a small handful of models, it can be fine to save all those posterior samples. But if you're running the model thousands of times, I recommend just saving compact summaries like these posterior summary statistics and convergence diagnostics, et cetera. And it's a bit friendlier on storage that way. And if we can visualize the graph after this to like we did before, I'm just showing this here to say that the graph can show a bit more information than just what's up to date and what's connected to what. So we have things that are stored in the metadata that you can report, like the number of branches here. You can say, well, how collectively, what was the what was the size of this data, and how long did things take to run? And as you can see, yeah, we're about 44-ish minutes collective total runtime. And if this were to fall out of date again, I would consider running this in parallel on a cluster, or across the CPUs of a local machine if I didn't have one. So we can continue to add targets to the pipeline. So suppose I want to perform the same exercise on a set of simulated data where the covariate is discrete. So I add a custom function. And let's say we also want to add an R Markdown report that depends on the upstream targets in a pipeline. So here's an R Markdown report that I put together. It uses functions tar load and tar read to refer to targets in the pipeline. And so you can run, so as long as you have a completed pipeline, you can actually run this report by clicking the knit button in the RStudio IDE like you would normally, and that'll produce the report. But not only that, there is this tar render function that is part of the extension package tarchetypes, which is sort of a companion to targets for situations like this. All you do is supply a name and the report file and other options that get passed to the render function in R Markdown. And this report automatically depends on upstream targets that you've referred to in the report itself. And so when upstream targets are invalidated, this report step will react to. So you get the best of both worlds here with R Markdown. You get integration with a pipeline, dependence on upstream targets, and you get the interactive. You get to run it interactively, so you can edit it like you would normally edit a document. I will say though that R Markdown reports are best served as components of large pipelines. You can run a large pipeline inside an R Markdown report. You can call targets itself from R Markdown, but R Markdown and knitr aren't really. They're designed to solve a completely different set of problems, and I would recommend against using them as sort of workflow managers for really large projects. They're great for small stuff. They're great for tutorials. They're great for summarizing results that are already computed, but I think they should do as little computation as possible and just serve to annotate and summarize and explain and display results that are already computed in a pipeline. And also, I'll say it's a really good habit to produce some kind of literate programming report as an artifact of the pipeline, or multiple reports depending on what you're doing, even just to keep track of what you've done and what the project is about and what all these targets mean. I recently returned to a Drake project that I needed to present on the next day, but I hadn't touched in about 6 months. And it was really complicated, a lot of custom code, this weird simulation workflow that I hadn't ever done before. So there were a lot of things that were a bit rough around the edges, but I looked at the report at the very end and he knew exactly what the targets meant. And not only that, everything was up to date. So not only did I know exactly what to go in and change to answer this sort of little question that I got asked from a colleague, but also the computation time to make that happen was really short because nothing had changed since then. And there's no way I was going to remember what happened 6 months ago, but Drake did and was able to salvage a lot of that work. But anyway, when you run this, it'll again run the correct targets in the correct order, make the decision to skip targets that are already up to date, and so it'll run this report last because it depends on all the modeling work that we've previously done up to this point. And so our pipeline at this point is completely built up, but of course things change, right? So you go back and you change a function based on new ideas you may have since you've last ran it, and targets will automatically detect changes in this in functions like this, functions in your environment. So we're making a change to the simulate data discrete function, and this is targets is going to notice that this changed, and because this function changed, so did the data, and then the model is put into question, and so is the report. And again, it's going to automatically run those targets and only those targets. And sure enough, when we inspect this report, we see that it does answer our original question. So we're not getting, we've been in the implementation side so far, but we haven't strayed from the original problem at hand. Our coverage rate in this case is about 91%, which is just above nominal. So that's evidence in favor of this model being implemented correctly. And likewise, we can include plots of posterior estimates against the truth and diagnostics and so forth. So at this point, with a completed pipeline, it's nice to check that everything is up to date again, because this is tangible evidence of reproducibility. At this point, you might step back and reflect on your work and reflect that things are up to date. And this sort of claim that that the output is synchronized with the upstream code and data, that's saying that somebody else could run this same code and produce the same results. That is the statement that this is making, which is central to the whole concept of reproducibility. Certainly not the only thing reproducibility means. Reproducibility is a general umbrella that encapsulates what it means to trust a data analysis project or any of the software stack behind it, and even the scientific methodology behind it. But this is using a pipeline toolkit for large computation that gives you this kind of evidence is part of that, and it's a really important part of that. So at this point, I'll say that targets is under review by rOpenSci, which is super exciting. We've got reviewers, and I'm excited to see what they say. They're people who I have a lot of respect for, and I'm really curious to hear what they have to say, and it's going to make the package a whole lot better. Because of the potential for change during that review process, I've been delaying submitting it to CRAN, but you can install it from GitHub. It's open source. You can install it from this repository with this command. And there's a lot of documentation that you can use to learn about it. So this workflow exists in a repository of its own. So does so do these slides, and the slide deck that I'm showing you right now is at this URL. There's a half-day short course which I taught at R Pharma and plan to teach repeatedly, and there's a user manual with some in-depth discussions about features, and then there's a reference website with all the functions laid out for you, and sort of a high-level listing of the external documentation in various places. And just to show you, one of the resources is actually an RStudio Cloud workspace. So if you go to the repo that this example is a part of, you'll see this link. I seem to have lost the Zoom's green box that confirms that I'm presenting. Can everyone see a GitHub repo on your screen right now?
Yes.
Fantastic, great. This is why I should use Zoom every day instead of Microsoft Teams. So the workflow that I've described is in this GitHub repo here. There are instructions about how to deploy it, what all these files mean, how to access, how to run it on a cluster. And if you go to this RStudio Cloud workspace, you will automatically be pulled into an instance of RStudio Server where you can run this code for yourself without having to install any dependencies on your own. All the packages and all the files will already be there. I know it's having a little bit of a delay refreshing right now. I thought I'd pulled it up in preparation for this, but there it goes. Yeah, so you'll get an instance of RStudio IDE, and you'll be able to, you have this pipeline, you have targets, and you'll be able to run what I ran and showed you today without needing to install anything locally. Likewise for the short course. So the short course goes through interactive exercises and teaches you systematically about the concepts involved in targets. It takes about a half a day to teach it. You start with the machine learning pipeline and you gradually build it up, starting with the functions and then the pipeline. Then you build up the concepts to more advanced features, and get deeper into this machine learning pipeline. And you're hopefully left with an understanding of the concepts after this. I plan to teach several more iterations of this at going forward, but there's nothing stopping you from taking it yourself. It similarly has another RStudio Cloud workspace, and all you need is a free account to be able to access it. So at this point, I will go to some live coding. So a lot of times I get asked the question, well, how does this all interact with Shiny? How does Shiny interact with these automated pipelines? And I'll say that there are a couple different families of use cases that I've seen. Number one is to have a targets pipeline inside inside a Shiny app, and I have colleagues who have done that at work. And there's another use case that allows you to automatically deploy a target at the end of a workflow. So you might see. So I've actually modified the pipeline for today to automatically produce a Shiny app to display the results of the MCMC. So instead of showing a lot of static plots, it might be nice to show summaries of an interactive collection of plots in a dashboard to say, okay, do I want to show the results for the continuous or the discrete version of this model, or this in terms of the covariate? And do I want to see means or posterior medians as my summary statistics here? If you scale up the number of plots, it might be cumbersome in a report, but in a Shiny app, we get it all in one view. And so I've added targets to the pipeline to make this happen. And so this pipeline and this graph here show that, yeah, so here we've got this target to deploy this app here on the left at the end, sort of over and above in addition to our report. So what I'm doing to make this happen is I'm exporting these results to a file, in this results file target, and I have this special export results function that I wrote, and all it does is just save an external file. This export results returns to the path of that file, and format equals file in tar target just says, okay, treat the return value of this command as a character string denoting the path to the output file, and then for future reference, hash this file and track it for changes, so you can invalidate targets at the right times. Next, we have a target to similarly track the source file of the app, and another to call the rsconnect package to deploy the app to RStudio Connect. And so to look at that deployment function, all it's doing is using this very magical deploy app function, and it's going to take the files it needs, and it's going to force update to shinyapps.io. And one thing I noticed right here is the first time I deploy this app, there's something that I already want to change. So there's this awkward white space here. because of this sidebar on the left is missing. I didn't supply a value and I didn't take it away either. And I want to make more use of real estate here, especially because I'm taking up half the screen here to show you all. So what I'm going to do is I'm going to go into this app.r file and I'm going to say, aha, I need my sidebar and I want it to be disabled. So I'm going to uncomment these lines. This is a change to a file that we've tracked with this format equal to file keyword here, this option in this app source target. And when I check the pipeline now to see what's up to date, what I'm going to get is some outdated targets. So this app source is out of date. And so this deploy target is called into question here. And what's going to happen is when I run the pipeline again, it's only going to focus on those targets that are in light blue here. So let's run tar make. And by the way, don't forget that these upstream targets are super expensive. These are MCMC targets. We have 40 batches of 25 simulations each of this workflow. And so I really don't want to be running those again, especially because I'm live coding here. I want this to get to the deploy step right away. And if I do this tar make, that's exactly what it's going to do. So it's skipping all these targets. These fit discrete targets took a long time. It goes straight to the deployment step. And this is going to take a little bit of time, but it's a very good use of time because it's exactly what needs to be done to synchronize the output with the underlying code. So this could probably take about a minute, and while this is going, I think I might be able to take a question or two.
Hey, so we got a few questions already. One is, do you always write a function for each target, or do you sometimes just write a quick expression there if they're using a deep higher pipeline, like select and mutate? Would you just put that right in the target?
So that's a great question. I think it's good practice to condense down the commands that you actually put in the pipeline. Even small dplyr pipe chains can get pretty cumbersome if you insert them here. You can do it. It's just going to get a little bit more difficult to read and maintain. So I like to write compact function calls based on either custom functions or just really short calls here to make sure that I can go back and have this tar pipeline call be pretty short.
Does it ever get, I'm going to do a follow-up for this person. Does it ever get burdensome? Like, oh, I just need to write, like, call 2 functions and I have to do it. So you go to put in all that time to write a function. I guess for you, that's not a burden, I guess, right?
Well, I think, for somebody like me who's used to writing functions, that may not be so burdensome, but I understand the desire to reduce the size of the code base, or if you're not comfortable writing functions, you don't have to write as many as I've written here. So I've written a bunch of utilities here to do nice things like silence some of the output and save results to a file, but you can certainly put these as just inline expressions in these commands, especially as you're getting used to more function-oriented style of programming.
And I think whoever came to Miles's talk a few months ago, he actually wrote an RStudio plugin to create the function for you. Maybe there'll be a targets version of that.
Yeah, so he's been talking about that. I'm not sure what the decision in his group is going to be, but they've certainly talked about. So he has a package called dflow, which is, it's a bunch of really nice stuff over and on top of Drake to make it just much easier to define and document functions, just magically really easy. This is exactly the sort of thing the sort of magic that I would expect from the author of Data Pasta. It's quite magical. But I think a lot of this, whether using targets or Drake or not, or neither, the same principles apply. And so I think that he's going to be able to reuse a lot of his previous work for this.
Good.
And I'll just, at this point, I'll say that our pipeline has completed, and we have this updated app now. Remember, previously we had this awkward sidebar, and it no longer exists. it's gone. And so you can sort of see that, see how you can see here the effects of running this pipeline. And the aspect ratio of this plot is much nicer on half a screen. And once again, if I run tar make again, having changed nothing, everything's already up to date. And so that's how targets itself works. At this point, I'm going to finish up the formal part of my presentation by addressing Drake. So I've talked a lot about targets, and I've said it's the successor to Drake. Like I said, I was originally nervous about releasing targets because it's asking a lot of the community to switch tooling. It's never something that I do lightly, and Drake is the most widely used thing I've ever developed, and it takes a lot of effort to be able to get on board with it. But there are good reasons why I've created targets. Over the years, as I've noticed inefficiencies come to light and notice users struggle and be surprised in certain ways. Initially, I kind of rolled with that and made up for it in documentation and tried to help people work around those problems. But I mean, eventually, over 4 years of development, we got to the point where Drake's most pressing problems were its unsolvable ones. So there are permanent things that I just can't address in the infrastructure because it's either too fundamental to the design or too fundamental to people's existing workflows that rely on features being the way they are. And not only that, I just learned to be a better, and this is not a reason why I did that, but at the same time, concomitantly, I learned to be sort of a better developer, and I've sort of confronted a use case where object-oriented programming and design patterns were, I mean, there was an actual reason that I came to understand to solve to see more of the problems they were intended to solve. All this came together in a higher quality tool. So Targets has stronger guardrails, and it's got lighter, friendlier data management, a bunch of improvements to dynamic branching, and extensibility in metaprogramming. And there's a statement of need with a bunch of these. A couple of things that I'm not covering here are its ability to debug stuff much more easily. There's a big section in the manual about debugging pipelines and targets. And that's already a whole lot easier, and it's something that wouldn't have been as possible in Drake. I'm also trying to make targets easier to use with sort of custom packages as workflows and tracking changes in functions inside packages that a user develops. That feature isn't quite there yet, but it's another one of those things that wouldn't have been possible in Drake that I'm almost there at implementing. Let's go through some of these main advantages. So stronger guardrails. So Drake is a bit flexible. So it allows you to define different kinds of caches and different kinds of locations. But with targets, pretty much the only way to use it is the correct way. It always does the work in the fresh, clean, reproducible R process to avoid detritus in the working in your environment. It's paternalistic about the working directory and the data storage, and it removes flexibility that has tripped people up more than it has helped. It just leads to a smoother experience. And as I was telling Jared before the official presentation, the data store is lighter. So Drake's cache is quite large with a lot of bookkeeping files. And it's really hard to put this thing under version control or recover when a file breaks. A lot of this is not only cumbersome and difficult to read, but also if one of these files is corrupted, it's very hard to recover. But Targets simplifies a bunch of this. It has the number of file scales is the number of targets plus 2, and it only the metadata here, targets meta is sacred. Other files can break, and the next run of the pipeline will just recover this automatically. The files are a lot smaller, and so that you can ship this to, for small projects, you can even put it on GitHub. For larger projects, you might want to look at something else like Google Drive or Dropbox, but the synchronization process proceeds a lot faster. And on top of that, integration with AWS S3 is seamless. You can declare an S3 bucket, and targets will automatically ship the data to that bucket and track it. And by the way, reading data in an exploratory data analysis fashion also connects to the cloud in the same way. And so interacting with cloud data also feels just like interacting with local data. Cloud computing is another story. We've got the cloud storage part solved, I believe, but cloud computing is going to take a little bit because of where R itself is in this space. I've got some conversations going in the open source community about how we're going to do this. Introspection is much improved as well. So targets can tell you not only which targets are out of date, but also which functions are out of date. So it'll allow you to sort of look at an out of date workflow and better understand about what changed since you last ran it. Drake does respond to changes in functions, but it can't tell you as much about which functions changed. So this feature in targets makes it a lot easier to sort of, it reduces frustration and increases transparency and reproducibility. Dynamic branching is a lot better. So dynamic branching means that in a pipeline, you define new targets based on the values of previous targets. So you're creating new targets as the pipeline is running. And you actually saw some dynamic branching today in the Bayesian data analysis pipeline. But dynamic branching, it's a lot more flexible now. So what you can actually do in this, as demonstrated by this code, is you can actually use dynamic branching to loop over subsets of a data frame where those subsets are defined by dplyr or group by. So you can define a group's data frame and use the tar group function to define the groups. And then every downstream target that branches over it will automatically create one branch for each group of rows. People have been asking for this in Drake since the very beginning, and it's finally possible thanks to this clean slate and the learnings that we've taken from Drake. Parallel efficiency in dynamic branching is a lot better. This is the most difficult but most rewarding potentially part of, well, one of the rewarding parts about targets. So Drake had this parallelism workflow that you see here, where if target B maps over target A in a dynamic branching fashion, there are these finalization steps in between. So this produces a situation in Drake where you have to wait for all the branches of an upstream target to start any of the branches of a downstream target. In targets, you're not limited to this MapReduce efficiency constraints. You can proceed to the next steps, the next branches, even if some upstream branches still have work to do. And this increases efficiency and reduces runtime, and it's more responsible with resources. Dynamic branching patterns can be composed, so you can for example, in this example pipeline, you can create a new branch for every combination of W and pair X and Y, and you can create sort of arbitrary dynamic branching patterns this way, which allows you to just select the targets you need without a whole lot of messy workarounds. And last but not least, there is metaprogramming opportunities, because targets isn't limited to the domain-specific language of Drake plan that Drake was limited to. So there were features in Drake that assumed that you were only going to define workflows through the Drake plan function, and targets tries to be more open. and say, well, there's, and define, it lets you define targets outside of a pipeline statement. So you can define target objects on their own and then put them together in a pipeline later, which is something you couldn't do in Drake. And there are ways to define targets without any non-standard evaluation. So this tar target raw function makes it really easy to program on top of things in targets. And it opens the door for extensions like target types, which you saw our Markdown report integration. That's exactly what makes this possible here in a very clean, maintainable way. And here is where I have a little announcement to make. I have a brand new package called stand targets, which is another one of these extensions made possible by the extensibility and metaprogramming capabilities of targets. And let me pull this up right now. So stand targets is an extension to the CMD stan R package and targets itself, and it makes it super easy to maintain to set up stand-based pipelines. And relative to this example today, you saw a bunch of targets and a lot of code. Maybe you didn't. Maybe you saw pattern equals this for dynamic branching and thought, what's that? It may have been confusing and intimidating. But if you're doing Bayesian data analysis like MCMC or variational Bayes, or even optimization, then stand targets can help you get the exact benefits of targets that I described, but with minimal custom code. You don't have to think about these advanced branching features. You can just get the targets you want and skip expensive computation. And this package is on GitHub. I released it literally yesterday. It just got approval to do so. You can install it from GitHub. And just to give you a flavor of what's possible here, this simulation study is pretty much the vignette that I describe here. A very similar model with a very similar pipeline. Now, instead of this long pipeline that I showed you earlier, it condenses down to just this. So to give you an idea of the pipeline I had before, it was about 80 lines, and you had to worry about formats and branching and settings and stuff. Over here, you just need this, and most of these arguments are specific to Stan. So you give it a model file, you give it a data generating function, and you just use this specialized function in Stan targets to say, okay, I want to do a simulation study with these number of batches and this number of reps. And in this case, I want to produce these summaries for the validation study that I described. You automatically, you have what looks like a call for one target, but you actually get several targets, pretty much the targets you had that I described in the main talk. And this automatically gives you this validation study. And again, and just a couple lines of post-processing, you have this nominal coverage that tells you something about the correctness of the implementation of your model. So this is gonna, I hope that this will be a game changer in specialized pipelines like this. You also have a function here to just take a single model, and maybe this is a big model that runs for a long time, and just run it once with a tarstan MCMC target. And you again call this small, very condensed, very simple pipeline statement, and you immediately get 5 targets, which are 6 targets in this case. So you have the model file, you have the MCMC object that's completely serialized and retrievable, and you have example sampler diagnostics and the actual draws of your MCMC, which you can customize, and summaries that you can customize. And you get all this automatically with minimal custom code. All you need is again a function or to generate the data, or a symbol that is just the data object and the model file. You really don't need to think about custom code here. You get all the benefits of targets. So that's out there now. And I think and I hope that this sets a precedent for other methodology specific packages. I mean, there could be a targets extension just for machine learning, or a targets extension just for, either whether it be Keras or Torch or tidy models, or other kinds of specific methodologies. I have colleagues who've written extensions for this for specific for sort of simulation studies in the life sciences. The possibilities to make this sort of thing convenient is really exciting, because all this time, the major limitation of all this is the burden on users to write their own functions and to write their own custom code. But if we have sort of pipeline toolkits that are specialized, that extend targets to specific methodology, where all this is already figured out, there's really not much that the user can be intimidated by. So I am really excited about where this is going and hope to take it further next year. And with that, I'll open up the rest of the time to questions.
Thank you very much for that excellent talk. I think if we all could be here, we would give you a virtual applause. I will applause for everyone. Hope that my little golf clap is enough in that microphone for everyone to be very happy about this. So thank you very much for that talk. And I would sit here and telling you thank you again, but we need to dive right into the questions. So first up, so there's a question: why not call RS Connect deploy app directly? Why have a wrapper function around it?
Well, it's just a stylistic choice. Again, it goes back to the first question. Why do I define this special deploy app function? And it's just style. Otherwise this underscore targets.R file could get quite large, and this tar pipeline call could get quite large. To split things up and make this short is usually something I end up thanking myself for doing.
All right, and then in a similarly related question, I'm not going in order they came in because some things seem like bunched together. What's the best practice you found for maintaining all these functions in like a well-documented way for using targets? Do you like document your functions using Roxygen? What are you doing?
Yeah, so I do use Roxygen comments. It's very natural to have the usual Roxygen tags that you see here that I'm displaying, along with even some examples to run them that are self-contained. I collaborate with Drake-based and hopefully in the future targets-based simulation projects, many of which were COVID-19 related and fast-paced, and it really helps to have examples of these functions in line, because I'm not always writing the code. I'm collaborating with my colleagues a lot, and I need to understand how their functions run because I'm contributing to their pipelines, and sometimes I'm reviewing them for internal validation purposes. So I think the most important parts of these are the examples that should be self-contained, and the explanations of what the parameters mean, especially if you're collaborating with colleagues and have a tight timeline.
Okay. Yeah, so Roxygen has been a blessing. So along those lines, there's a question here. But what was tar script versus the tar plan?
Oh yeah, tar script just writes a targets.R file automatically. So what I can do is we just open up a terminal here, and yeah, I didn't mean to actually focus on tar script because it was a little bit of an unnecessary distraction for persistent projects, but just for the sake of getting things set up easily, tar script just writes code automatically to an underscore targets.R file. So for example, you could say tar pipeline, tar target, and that would automatically write that automatically writes this targets.R file here. The function that I think is a bit more useful here is actually, let me close out some of these files just to make it more apparent. So there's this function called tar edit, which automatically defines a targets.R file if it doesn't already exist, and it opens it up in the RStudio IDE. And this is actually, so tar script is mainly to help people who write documentation and produce reproducible examples to share in bug reports. But tar edit is for what people are going to be using most often to access this file.
And then since I'm not sure if Miles is here, will that also work in VS Code?
I'm not sure. I would definitely have to defer to Miles on that one.
All right. Challenge, gauntlet thrown down to Miles. If he's not here, all right. Then we have a question about.
Actually, I can answer that one that you asked. To the extent that use this edit file uses VS Code, which I don't think it does because it uses the RStudio ID API, it looks like. But to the extent that use this edit file works in VS Code, that could work in VS Code as well.
And I know someone, the person in charge of the VS Code, our package or whatever, I'm not sure what they call it, I think they call packages maybe, did talk about something about how they can replicate the RStudio API a lot in VS Code. I remember seeing a tweet, but I don't remember exactly, so that could be cool. All right. This is not a question, but a comment. I just wrote a simulation-based calibration for a stand model this morning. This package looks fantastic, so kudos. You could have solved this problem. You gave the talk yesterday. You could have solved this problem.
Glad to hear it. I'm sorry it was a little bit too late.
Yep. Hopefully this will be helpful going forward for him. Then the two questions, actually, I'll condense them into one. No, they are separate. Yeah, again, they're related. Is there some sort of well, I'll just do the second one. Does targets have functions to transition from a Drake workflow into targets?
Not explicitly to automatically make the transition, but I've tried to help where that's concerned. So there is documentation on how to do this. So if you go to the, this is my personal website, but if you go to, maybe it's in the manual actually. Let me go to that. So at the beginning of the manual, there's this "What about Drake" section in the first chapter, and it turns out that if you know Drake, you almost already know targets. And so what you can do is you can go to this table and you can see how the Drake functions that you use map to their counterparts in targets, and the mapping is mostly very smooth. So you have functions, and you not only have that, you have arguments to make and see how they map to arguments and targets, and you have optional Drake plan setting, which map to optional target settings. The other thing that I'll say here is that I took Miles's advice about and his comment about that not everything in targets is easier in Drake, and in tarchetypes I actually created this function called tar plan in tarchetypes to make usage a lot easier. So if we go to if we just pretend this is a new pipeline file, we could do something like tar pipeline tar target x simulate, and then another, let's see, data. So we have a pipeline here, and this is actually equivalent to something that you would ordinarily see in Drake, where you have a more intuitive assignment. Mm-hmm. If you have custom settings, you'll have to fall back to tar target, and you won't be able to do this assignment within tar plan. But tar plan for a lot of use cases does have the ability to define pipelines in a very Drake-like way, and Miles has used this and reported that it's a lot easier to transition. Mm-hmm. And you can even combine very different parts of different pipelines. If some of your pipelines need settings like format equals FST TBL to make custom compression to speed up the process and lighten the load. If you have different pipelines that if not everything you can do in tar plan, if you have to use tar pipeline for for some things. You can actually put this stuff in here, but there are ways to actually combine. There are actually ways to combine these pipelines together. So maybe that last bit was a bit off topic, but I've tried to make the transition as easy as possible in spite of the manual work that's required.
I actually like this turning to a personal question of mine. I know I talked to you about this on GitHub, and the last day you said it wasn't really feasible. I have some projects where I'll have like 5 different Drake pipelines going separately, but together, and they sort of, sometimes they feed off each other, other times they're isolated. It almost seems like if I separate them like this, it allows me to keep that separation.
Yeah, and you can even you can divide these up into different files. You don't need this monolithic tar pipeline call. I only put it here because I didn't want to avoid introducing too much, but you can do things like, like I said, define these in different files. You can even define lists of target objects on their own. So do something like this, and you can even have multiple lists of targets. This is equivalent to what I showed before, except for the syntax error. Oh, there we go. Yeah. So these are target objects, and they're just there's a lot of structure, but I guess as you can see, a target object is just a fancy environment with a bunch of data inside. So these objects exist on their own outside of any domain-specific language. So you can treat them as such, and you can supply arbitrarily nested lists to tar pipeline.
Nice. That will be very helpful, at least I know for my use case, hopefully for other people's. All right, cool. That's actually, I'm very excited for that, because I know that's something that one of the issues I talked to you about months ago. So that makes me very, very happy to see this.
Good.
And related to that, a question just came in. Is there a way to, and there's more questions, by the way, this is one just came in about that, so I'm going a little out of order because this seems like a nice follow-up. Is there a way to use a variable to determine which targets run, say if you want to stream for morning versus afternoon?
Oh, that's a good question. So you can programmatically configure the pipeline to do this. You can have, you can programmatically put the pipeline together like I showed, and there's really nothing stopping you from selecting targets in this list. Targets also support something called queues, which are kind of like Drake triggers. See this queue here, you define through the tar queue function, and you can select if it always runs or never runs unless it's missing, or and a bunch of things you can select to determine, there's decision rules to determine whether to run it. And on top of that, there is a tar change archetype in the tarchetypes package, and this allows you to define some code that determine that's going to always run. This is going to turn into a target that always runs, and that's going to be upstream of the main target. And this could be something like checking, is it morning or is it afternoon? So tar change makes arbitrary queues a little bit easier.
Okay, so sounds like tar change might be the one this person was looking for.
Mm-hmm.
Then we have an earlier question which sort of ties in there. How would you schedule this targets plan to run on a daily or hourly basis? Because before we had this video call, I talked to you about Connect could schedule things, but if you're not using Connect to kick off targets, how do you schedule targets? What do you use?
So this is not something I often encounter. I may in the future based on some projects that are coming up, but outside of something that looks or acts like cron, I'm not exactly sure. I mean, targets itself doesn't exist on a timer that runs at a specific schedule. I think that's something that Airflow tools are more interested in tackling, but on the other hand, there's certainly nothing stopping you from setting up something like a cron job to automatically run a targets pipeline on the hour every hour or something to that effect. I think that targets itself will play nicely with those scenarios, and tools that accomplish this, elsewhere in the R community will also accomplish this here.
Okay, so stuff outside of any scheduling service that you would like.
Yeah.
Okay, which cron has been around for a while for a reason. There are R packages for cron if you don't want to use cron itself. There's an R package for Linux cron, there's an R package for Windows equivalent, which is cool. All right, so then, what if you have a Shiny? If you had a Shiny example earlier, I'm guessing. I know you had a Shiny. I'm guessing that's why the question was asked. The Shiny app depends on data that could change while the app is running, and you want to run that data through a targets pipeline. How would you do that? Since the example you showed had targets deploy Shiny, how would you, have Shiny use targets?
Yeah. So is this a question about data dependencies of the kind of Shiny app deployment workflow I had, or is it more of a question of I have a Shiny app that runs a targets workflow, and how do I make that happen?
From the wording of this, I'm going to guess that you get data in, and I'm guessing that it has to go through a series of steps before it's ready to be shown by Shiny. But it's like data that changes is what it seems like, versus data that would be static each time you deploy. Like you're hosting this thing, and next week the data changes. But
Yeah.
Yeah.
So I think this pipeline attempts to solve that problem. So if I'm understanding correctly, we want the app to be deployed when the data changes, right? And so that's what this target does. This results file. It takes the results of the MCMC, it externalizes it, and it tracks it as a file. And this is actually a dependency of our app. And so before we ran this, so this results file is a dependency of this deploy step. And so when this file changes, that's going to invalidate the deploy step, and it's going to trigger another deployment to RStudio Connect.
I think they were asking the other way around. I'm reading into the question now, though, so I'm not sure. Yeah, maybe they were asking what you asked, but I think they're saying, like, I know some people, they have like a Shiny app that reads from a database, and each time you click go, right, it reads from the database again, which wouldn't have to go through a series of steps. But I'm not sure. I'm guessing what they're asking. So
yeah, so this sounds like a situation where you'd have potentially a pipeline inside the Shiny app that may have an expensive computation on sort of when the user clicks a button, it checks the data, and if the data is changing, it does some expensive processing or something. It seems like that could be use case that if the app has access to a file system, a persistent file system, to maintain the target, the output files that targets generates. It seems like it can be handled that way. One of my colleagues built a COVID-19 simulation app, and he did a similar thing with Drake, actually. So it's those sorts of things are possible. It is a large undertaking because of the session management and file system management that has to happen inside the app, but it is being done.
Okay. All right, so hopefully that answers the question. Then someone, actually, they just got a comment in referring to something you were just talking about earlier, was I often use tar change for targets, and I often use tar change equals sys.date for targets that should be updated every day. I've used that trick in Markdown, so.
Yeah, that sounds like it'll work.
Nice. I assume, do you still have time to answer a few more questions?
Absolutely, I've got all night.
All right, well, wonderful. We're going to crack open a beer. Let's do this. Someone is asking, can these targets be stored and documented and tested within R packages?
Oh, that's a good question. So I'd actually, and I get asked about automated testing within a context of pipelines quite a bit. And I would say that it can be a good idea to maintain the code behind an analysis in a package. If that's your style, you can do that. I'm working on making the tracking of changes in those functions a bit easier. But as far as testing goes, I think that tests should happen on, just like in a package scenario where you have scaled down tests that are targeted to sort of very, very limited examples for functions as sort of built-in unit tests. Mm-hmm. So unit tests are great. They catch regressions to old bugs, and they should be used as often as possible, but they shouldn't necessarily be computationally expensive. And that's where some of the difficulty comes in here, because these pipelines are computationally expensive. And sometimes, especially for the Bayesian validation study I described, you may have to run this quite often in order to actually be able to tell whether your results are believable and are correct. We spent this entire simulation study just to check the nominal coverage of a parameter. But I would say that unit tests themselves should be independent of the pipeline on individual functions, and then the pipeline itself could be a form of test or validation of a method that you've put together. But there's nothing stopping you from writing test that unit tests either in a test that folder in the workflow itself, in the pipeline itself, or in a separate package where you've implemented most of the content of the research. But just to keep the unit test as sort of both conceptually and physically separate from the pipeline is a strategy that I've come to recommend.
Okay. Yeah. So like they say the same thing in Shiny. Make everything as much of a package as possible, so that's easy to test, and keep that out of the Shiny logic.
Mm-hmm. Exactly. They're different things that solve different problems that work very well together. When both pieces are physically independent but supporting the same goal.
I like that. I was just thinking, when I write a lot of my package tests, it's like, oh, here's a function that takes the input of this other function from the package, but that's one, maybe 2 hops only. Targets probably be overkill for that anyway.
Mm-hmm.
I mean, I can imagine just what Cran would do when you just set up a test that's going to run for an hour.
Oh my gosh. Yeah, that's the sort of thing we want to avoid. Tests are run early and often, and so we want to make them light we want to be nice to the infrastructure that the Cran maintainers have been generous enough to afford to package developers like us.
Oh yeah. They had to get compute time somewhere. They have servers. It's a lot of work what Cran does.
Yeah.
Yeah. So here's these are sort of related. One's a comment, so I'll do these. So first, I think Noam actually answered the Miles's function mate works great with both Drake and targets. So that's nice to hear. So that's good. And that steps into the next question. Do you think we'll ever get to a point in R where we can targets-ify an arbitrary R script via static code inspection and beyond? So I guess you give it an R script and it creates targets.
Oh my gosh, that is a dream, isn't it?
Yeah.
Through static code analysis, crawl through a script and turn that into functions. I would love to see that. I haven't personally decided to solve that problem, but there is actually an ROpenSci package called rclean that does something similar, where you identify an artifact that's produced somewhere in this long, complicated script, and it goes through the static code analysis necessary to just return the lines that are important to only that object. Wow. And this helps. It's more for a readability thing. And to aid refactoring as well, if that's something that users are motivated to do. But it seems like if that were possible, that's kind of what that would look like. And maybe it's an extension to rclean, maybe it's something else. But I mean, similar users have tried similar things. In Drake, actually, there was, to sort of ease the friction of moving from scripts to functions, Ellis Hughes from Fred Hutch actually wrote an extension to turn a script into a whole script into a function that behaves in such a way that it integrates nicely and safely in Drake pipelines. I've kind of resisted that for targets itself, because I don't think so. Targets is more about paternalism than flexibility, and the child proofing is super important, and it's part of the intent of the package. And I know that causes friction, but I'm really hoping to make up for that with packages like stand targets, where you barely even have to write custom code if you don't have many custom targets to add after the main automatically implemented processing steps.
I mean, I'm fine if you're making more work for yourself, so that works out.
Yeah, the dream is to have a whole targetopia of interesting packages.
We're gonna come up with a checklist of other obscure things you need to support now.
Yeah. No, it's all good. It solves a problem I've been trying to solve for years about being able to help people who clearly struggle with the workflow issues that Target solves, but don't really have the activation energy to get over that barrier to adoption. And I've actually, this came from my colleague's life sciences specific simulation package. Internally, he wrote this really thin layer on top of Drake. It's proprietary, so I can't share it, but after 4 years of trying to get people internally to use Drake when they were struggling with computation and just getting glazed looks back, this really thin layer was immediately adopted, and it was amazing because it was the same thing I'd been trying to do for years, and it only required this little push. And I'm trying to, with stand targets, I'm just trying to make this little push in methodology specific areas to reach people where they're at. And this is just the beginning.
Yes. Yeah, so Andrew Gellman will be speaking at the conference on Thursday, so I think he'd appreciate seeing the stand targets thing.
Oh my gosh! So to have the eyes of somebody like Andrew Gellman, that's a big deal.
Nice. I'll send me an email. I'll send it to him. And we have Jonah from his team and Rob Trangucci. They taught a workshop recently back in April for the meetup. So we're the stand team is very much loved in this community. And they're very involved. So you'll definitely get some hands on for you with them.
Awesome. Yeah, I've loved interacting with them. I've been talking with Jonah quite a bit about CMD Stan R, and he knows about stand targets, and I'm hoping that we can we can help each other out going forward. And I've enjoyed collaborating with him and his team.
Everyone loves Jonah. All right, everyone just loves him.
Yeah. So friendly.
Yes, he is. And he's done so much. I remember my wife needed to use Stan for research, and I asked Jonah to make a feature, and he made a brand new feature because she needed it in her research. So he's awesome.
Yeah.
All right, so enough fawning over Jonah. We could fawn over him. There was a follow-up to that question about the static target. Oh, actually, before I get to that person's follow-up, I'm throwing a challenge to you. In RStudio, does have a thing where you can highlight a bunch of code and it will turn it into a function. Have you seen this? So it's theoretically close. I know it's not even magnitude, but it's close. Huh.
That's interesting. And this is not part of FunctionMate. This is
go to click code on your screen.
Okay.
Extract function. A little higher.
Oh, okay. And I have to highlight something, right?
Write some R code. It probably has to be sort of a few lines of R code and extract function. Let's see if that works. Yeah.
That's really cool.
Yeah.
It identifies the global variables here to produce the signature, I assume?
Yeah.
Oh, that's cool. Wow. Yeah, I think that I might start recommending that now. That is really cool.
Yeah, it's really handy.
Yeah. It's exactly the sort of thing Miles would write. Did he write it?
This has been in our studio for probably like a decade now, right?
Wow.
Full code.
Such a, wow. I would, this is such an underrated feature.
Yep. Yes.
Wow.
Yeah. Right.
Yeah.
So hopefully that'll get us closer to that person's question. Let's see who asked that question one day. Oh, that was Henrik. Ha! Henrik asked that question. So now you have to do it. You've seen this. Henrik asked. You have to do it.
So what is there to do specifically? Is it to
Arbitrary R
spread
script.
this?
Make a plan out of it.
Oh, right. Yeah.
Yeah.
I'll think about that.
All right.
I'll keep thinking about that. No, so I still believe in the stand target strategy of reducing the code that needs to happen to begin with. But I understand the push, and it's well taken, and I'll keep thinking about it.
And good, because he had a follow-up question. And if that doesn't exist, which it will eventually, it sounds like, challenge, what about generating a skeleton from a script where most things are filled out, but not all?
Okay. So like a function script skeleton or a pipeline skeleton.
Yeah, sort of like your plan thing you have, I guess, right? But more tailored, I guess.
Yeah. So the interesting thing is that it's a very general use. So I'm not exactly sure what a skeleton would need to look like. Here's the closest I've come. So if we start R again, and I'm in a different working directory than the stand based project. So if I say tar script here, with no code supplied, what it's going to do is it's going to just populate an example workflow, and which is pretty small and pretty extensible. So I guess that's part of it. But I do kind of have trouble wrapping my mind around something that, how do you establish the patterns of something so general? It's easy if you know the goals of a specific pipeline or a specific methodology, but yeah, I'd be open to more ideas about how to do that in the general case.
Just use GPT-3 and have it do it for it, right?
Oh, fair enough.
No, all right. So Paul Puglia jumped in here, saying there's a rcvp.package.skeleton. And so all these things are just skeletons. I think Henrik is trying to get at like a more tailored skeleton than just a generic skeleton. So that's my guess. You can
like a more in-depth one where it also sets up functions and template files for a cluster and things like that.
But within reason, yeah.
Okay. Yeah. It's definitely a good idea, and my colleagues have wanted something like this for their workflow specific packages or life science specific packages, and yeah, maybe in archetypes, maybe I don't know. We'll have to get some discussion going and see what something like this would look like.
Nice. So Henrik just chimed in. Yes, a skeleton generator that tries to infer as much as possible from a script, and that as much as possible is what becomes what's realistic.
Okay, so to infer as much as possible from a script. So it sounds like you would already have some code to start with,
yeah.
And it seems like maybe parts of the script can be automatically turned into functions in the same way the IDE does. And
how do you choose which part? Yeah, that's hard, but.
Yeah. So, I mean, if you have an externalized a script file for an externalized R Markdown report, where you have comments for code chunks, that may be a little easier. But I would. It seems like that, but even that's very specific. So I don't know.
It's sort of like how there's an R Markdown thing. But you can write an R script by putting a special comment in. It'll treat it as if it were a chunk. So if someone went in like decorated the file, it might be possible, but
Yeah, sort of a decorated file would that already opens up a lot of possibilities.
Yeah. All right. So I'm gonna leave you and Henrik on GitHub to go and make something happen. I'll give you 2 of you 3 months, and we'll check it.
That's fair.
That's why we do things at this meetup. I had years ago, Michael Caine and Jay Emerson. They had a big memory. It didn't work on Windows. So I said, okay, we're going to sit down before the meetup, and we're not leaving, going to the bar until we solve this for Windows. We sat down, but I very quickly saw that in the package description it said operating system Unix only. I was like, just delete that line.
Oh, it's like the classic story about how people first tried to solve all of AI, right?
Yeah. Yep. Nice. So another question we have for you is, does targets keep a history of targets, e.g. a copy of the data for each iteration change?
That's a great question. I'm happy you brought that up because that's another difference between Drake and targets. So Drake is a bit of a pack rat, no pun intended. Its data store is, I mean, I don't maintain that data store. Its data store is actually designed to hold on to old data and to try to, as long as you don't garbage collect anything. And I actually use that to implement history, not only history, but also data recovery built into Drake itself. And it's sort of made up for the lack of sort of version control because of how strange and complicated the file system was. For targets, I made the deliberate decision not to implement any history or data recovery. And the reason is I don't want to get into that. Targets already does a lot. I think it should focus on just the problems that it set out to solve. But what it does do is, like I said, it lightens the data store. It makes the whole system a lot more readable. The file names are informative. There are far fewer of them. You can even put small projects on Git and GitHub. And for larger projects, potentially Dropbox or OSF or some other system. And the goal is to make targets play really nicely with third-party version control systems that will do a much better job than anything I could ever implement. And I think that based on the uptake, I think it's succeeding in that. One of the best parts is if you use the AWS integration that I talked about, you basically get data versioning for free because it's super easy to turn on versioning in an S3 bucket. So you can do that versioning already through Amazon tools.
Great. Because I remember that was a big thing in Drake, and I remember I was got to delete my whole thing here because it's taking too much space.
Yeah, there are functions to garbage collect Drake caches, but often I found myself just deleting the whole thing, or when a file is corrupted, if I'm copying it somewhere, it's because of the esoteric names, it's hard to diagnose where that even comes from. And it's another reason to delete the whole thing. But like I said, targets caches can just recover themselves, and as long as the metadata isn't corrupted.
Yes. Because I definitely did rm-rf on the Drake cache a few times.
Yeah. Hopefully less now in targets.
Yeah. Less burning it all down.
Mm-hmm.
Then we have, this is the last question I have unless something sneaks in. What would be your approach for translating an existing project, not a Drake project, but like an existing project into a targets project? So I'm guessing this is more like, hey, what's your methodology, your best practices? Like, do you have any like general purpose recommendations? I'm guessing that's what they've asked.
Yeah, so this goes back to Henrik's suggestion about writing skeletons and automatically converting parts of scripts into functions. And the farther along you are in a project that is not function oriented, the more difficult this transition is going to be. And and even automated tools may not solve that because static code analysis can't predict the return value of functions. So, and you got to make sure those functions have sensible return values and minimal side effects, which involve other programming decisions that can't really be automated. So, what I would do is I would take a step back, no matter what stage you're at. If you're committed to transitioning to a targets workflow, I would take a second to think about, okay, what are my data sets? What are my analyses? What are my summaries? And what is a function that expresses each of those steps and each variation on those steps? And inside this function, how can I express that logic in a way that has a very defined set of inputs for arguments, and an understandable, easy to work with single return value from that function. And I would just, that's always how I would think about making that transition or starting a project from scratch.
Yeah. Yeah, I like that. It's like the first time I used Drake, I had a 4,000 line project and I decided to translate it all into Drake code. And it was worth the effort. It took a lot of effort, but it was worth it.
Awesome. And I'm glad to hear that. And the trade-off is different for different people. So here's a little bit of an origin story. When I was in grad school, I was working with this massive Bayesian hierarchical model. And it was working on a paper, on a few papers with it. And this thing would take hours and hours, up to, for the whole dissertation, the whole workflow took about a couple weeks if we were running it to end to end. And I implemented an R package to do all that. And it was clearly a situation where I should have been using the available pipeline tools, but I was just too far downstream. It was too developed for me to pivot that much. And that's okay. If you've already got a workflow that works for you, or workflow is already too far advanced to be able to change easily, then that's fine. Now you understand the problems that you encounter with these large projects, and you understand the value of pipeline tools, and maybe your next project uses one. But my advisor would always, Jared Nemi at Iowa State was always telling me, if you used Make, you could solve a lot of these problems. You could skip computation; it's already up to date. You would have these defined steps here. And Make was just hard to work into what I was doing. And I took his comment under advisement, but I didn't implement it right then. And I think I credit his initial advice and his concern for the welfare of grad students and workflows in general to the fact that I became interested in this area of development to begin with. I mean, without that project and without his planting seeds, there would be no Drake and there would be no targets. There would probably be a remake, but remake was the predecessor to Drake by Rich Fitzjohn. But I wouldn't have gotten involved. And this is some of the most gratifying and rewarding and impactful sets of things that I've worked on.
And
anyway,
that actually made me come up with a question of my own now.
Mm-hmm.
And I don't mean to step on the toe. That is rewarding. I'm very happy that's been impactful and rewarding for you. It's been rewarding for me using it. So I can tell you, I'm sure it's been rewarding for many, many other people using it too. I know I think Amanda Dobbin gave a talk at our conference. I'm not sure it was last year or this year. Years starting to flow together. And she gave a whole talk about Drake. We've had other talks about Drake, and I've seen other meetups do it. So I could tell you that it's been impactful for a lot of people.
I'm really happy to hear that. This is one of those ideas that's so strange and unfamiliar. And I mean, because of where I was coming from, I could immediately see the value. But I guess you never know. And I'm just really glad to hear that people like yourself and others have benefited from using this, that it makes data science easier and smoother and more reproducible and more informative.
Yeah. It's I think a lot of people, I hear a lot of buzz about it. It's very exciting.
Yeah. And I have to say that the community feedback that I've gotten and has taught me a whole lot about what a pipeline toolkit should do. If I were just working on this myself, then it would be, the results would be unrecognizable. I would have solved, the initial one or two problems within a couple of months, and it'd be totally unrecognizable. The thousands and thousands of comments have built up my own knowledge and raised the bar for what a pipeline toolkit should be. And it's unreal the amount of that I've learned from just talking with users along the way. And I've tried to channel all that this past 4 years of learning into this new ecosystem.
Nice. Yeah, good. That's what open source is for. Is that
Yeah.
right? Yeah. And so I hate to step on that beautiful moment, but I'd have my own question to come up here. You compile stan, you can cache X. And a stan is a compiled C++ that's stored in memory. So and then let's say talk about an RCPP function that's not in a package, but you compile right as part of a target. Can you cache those and just reload them without having to recompile?
That's a good question. C++ code, compiling in memory and then storing the executable in memory, that gets tricky because, yeah, I haven't done that personally.
Isn't that a stan model though? It's the same thing. Like when you compile it, it's a compiled C++ program.
Yeah, and that's one of the reasons I actually chose to build on top of CMD stan R rather than rstan, because CMD stan R completely it doesn't use the memory system in R. It writes the executable directly, and it doesn't depend on what R session you're in about as far as the decision to recompile a model or its ability to use a precompiled model. rstan does a lot of things that are uses model objects in memory in such a way that sometimes makes it hard to use, that I've struggled personally with pipeline tools that use rstan, or pipeline situations that use rstan. It's certainly possible. And each time I've worked out some issues and tried to avoid sort of session dependent behaviors that rstan deliberately opts to. But I think that whole those kinds of objects in general get tricky because for the purposes of targets, a target is an object that can be stored to disk and then read later with no loss of integrity. So to serialize a compiled object can get somewhat tricky in that regard, especially if you're in a distributed computing scenario where you compile locally and then you're using that compiled model on a different node of the supercomputer. It can I've had some strange things happen, and C++ code in general that's compiled inline, using the tools like RCPP. I mean, those unexportable objects, as Henrik likes to call them, can be troublesome with targets. Some objects like Keras models and Torch models have special serialization functionality built right into the package, actually, to make all that work, because those are very common use cases. But for the purposes of stan, I've just decided to go with CMD stan R.
Okay, that makes sense. That's a good solution. Okay, cool. So I think I've exhausted everyone's questions. So I'd just like to end that for everyone listening. Hey, this is open source at its best. Will wrote a package, got thousands of comments, lots of GitHub issues, and adapted them, made a new package. I think we've been running this open statistical programming meetup for I think we're on 11 years now, and it's been a very beautiful group of people, amazing people who are very smart and kind. And so let's all just keep that going with open source. Let's ask nice questions. Let's ask new features. Let's contribute to them and encourage these open source authors to keep doing great stuff. So thank you, Will, for this talk. But thank you for the packages and contributing to open source that way. So thank you very much.
Thank you so much for inviting me. You have such a high impact, incredible group of the people in this meetup here. It's been super exciting to be part of it.
Great. I'm glad. I'm glad there's a silver lining in the pandemic and we're going to try to continue this once we go back into in-person. We've been filming the meetups for a long time. We tried live streaming them in the past, but audio problems. We're going to make an effort to fix our audio problems this way. We can have these live for everyone even when we go back to person, because we have people from all around the world. I know you're here, I know Henrik's here. I saw we have some other people from other continents, other cities in America. We really look forward to being able to continue that and keep everyone going, because why should we be geographically limited?
Right. Completely agree.
Yeah. So thank you. I know it's getting late. You are in the East Coast time zone, but I know we have some Europeans there hanging in with us. So thank you very much. I look forward to seeing you around. We have the conference these next few days. Hopefully as many people can join, and hopefully the next few months we'll see you virtually at the future meetups. We have January, February, March. We're going to have those lined up. We're planning at the following months. And thank you for coming. And everyone, if we give a virtual round of applause for Will, I'll go for my microphone. Thank you very much for attending. It's not quite the same as when we're